Alrighty. Got one person watching so far. Take some Mars Black, which is an iron-based pigment. Just going to measure out a little bit of ferrous sulfate here, which will be our iron 2 source. I think I'll measure out about 10 grams. Maybe we'll go a little bit more. We'll go 15. And then we've got our ferric chloride here, which we will, what should we mix that in? We'll mix that in here. Last pair of gloves, unfortunately. So essentially, to make Mars Black, we're wanting to make up a solution that is 2 parts of an iron 3 to 1 part of a iron 2. So that means I'll need to measure out 30 grams into here. Ferric chloride has gone really hard in this jar here. Hopefully we got enough of it. Let's see how we go. This is my second attempt at making Mars Black. What have we got here? People on Instagram. I just put the call out on Instagram if people want to come and watch. So we'll see. I need about 30 grams. Of ferric chloride. We're at 15 grams ferric chloride. $25. God. Yep. 30 grams. And get some water onto that. You can find my water. Ferric chloride is exothermic, so it's warming up quite quickly there, which is pretty cool. We'll just let that dissolve for a moment, and we also should probably dissolve our iron sulfate. A little bit of water in there too. people on Instagram know that we've started. This ferrous sulfate isn't very pure. It's a lot of impurities in there, so I might have to filter this before we go mixing them together. Yeah, there's a whole bunch of junk down the bottom there. Let's get a little filter flask going. Where is my filter flask? I just washed all my glassware the other day. So we'll just use this Elamina flask and we'll get ourselves a little funnel. This funnel should be good. Yep. It's a really simple cotton wool in the funnel here. That'll help us filter out any junk that's floating around that won't dissolve, but maybe I'll just keep trying to dissolve this ferrous sulfate first. Oops. The filter. All these iron compounds have that very distinct iron smell to them, like rust. Well, the ferric chloride dissolved pretty nicely and very cleanly, and it's warm, but it's not super warm. I should check whether that made it to Facebook as well, my announcement. This is my first time live streaming pigment making. I don't know if it's something people will be interested in, but we'll see how it goes. A couple of people have seen it. Filter spout, the stem of the thing here. I don't even know what to call it. Funnel. It's a funnel, that's what it's called. Yeah, it's much clearer now, so much nicer. That to the side for now. What are people on Instagram saying? Well, we'll let these sit for a moment. We'll also decide what other pigment work we should do today too. See, one of the problems with working with making Mars pigments or iron compounds is they stain glassware. It's kind of hard to see there, but you can see the stains on the glassware that I've just been soaking these in a special glassware detergent for a few days and they still haven't come up nice. So I might just have to relegate this beaker for only doing iron pigments in now, because it's kind of a bit stuffed for doing other things. So we've got 3 people watching now. It's kind of weird getting used to this whole live streaming thing. So I'll chuck this, the ferrous sulfate. Let's pop that in the beaker. I should prepare an ammonia solution as well, or still haven't decided whether I should use ammonia to precipitate out the Mars pigment or whether I should do sodium hydroxide. Or actually, I might do potassium hydroxide. Give me a second. So some potassium hydroxide here. That will help us. That'll be our alkaline to help bring the Mars pigment out. And so we'll need to make up a solution of that. So let's get ourselves a clean beaker. We'll use this one. We'll just wash it out a bit. Good. Make up a solution of potassium hydroxide. The potassium hydroxide is also exothermic, so this will heat up. I'm going to make a fairly strong solution here, I think. Move this out of the way so you can see what I'm doing. We'll let that dissolve. So essentially I've been working on a new set of watercolors, which I can grab some of the colors that will be in the new set. So we have this purple color here, or purpley pink color, which is a cobalt phosphate. And then we have this mint green here, which is a cobalt titanium pigment. And we have this, which it's not coming up the color very well, but this is a manganese blue that I've been working on. And then we also have, which I don't have any of the pans here, but we have this cobalt purple here, which is another cobalt phosphate, but just a darker one. And so I was thinking this purple with the sort of fuchsia color, the mint green, and the manganese blue would pair nicely with a black. So like I've got a commercial Mars black here. Mars black's like a little bit warmer than your regular black, and so I thought like pairing those pastel colors with a sort of deep but warm black that's not too cold would be really nice sort of pairing of colors. So our sodium hydroxide looks good now, so let's move on to the next step. So make sure everyone can see what's going on. So I'll add my iron 3, iron 2, add them together, like so. It's really stained now, so I'll have to make sure I wash that well. And then it's just going to be a simple case of stirring. Now, I could use a magnetic stir bar, but because what we're technically making is magnetite, that will just stick to the stir bar and it'll be an absolute mess. So what we're going to do is just slowly add in the sodium hydroxide. Getting the precipitate. In fact, I think I might go ammonia. I think ammonia will do the job better than the potassium. We get the stirring going again. The ammonia. We're going to need a lot more ammonia. We're just making iron hydroxide here, not magnetite. So let's just keep going. This is regular store ammonia. Nothing fancy here. I think once the pH gets to a certain point, we'll start making magnetite. So far, nothing. Let's go again. If I've got more ammonia, we'll have to go back to hydroxide. Oh, all right, we're starting to get black formation. Maybe I can just go with the hydroxide now. Yep, there we go. Wow, that thickened up really quickly. It's now like really thick in there. I think we need more alkaline though. So more sodium hydroxide. That's pretty black. That's good. That's what we're after. Happy with how that's turning out. All right. Bunch more and give it a stir. It's looking pretty good. Yep, there we go. A big beaker of essentially black sludge, but it's exactly what I wanted. Beaker with the ammonia smells. So all right. So really, is this warmed up much? Not really. Oh god. This is why I shouldn't live stream, because everyone gets to see how messy I am when I work. So, can everyone see there? This big beaker of blackness, essentially. Great. So now the main trick with this next step will be, I'm going to let it settle out. We'll tip off some of the excess liquid. Oh, thank you. I'm glad you enjoyed the new cobalt one, which I have a little pan of it here I was showing off before. It was really cool to discover that cobalt pigment because I found like a research journal on it and tried to recreate the experiment they did in the journal. And I ended up with the mint green instead of what was supposed to be sort of a deeper, sort of more lime green. And I'm fine with the fact that it turned out not correct, because this result's actually more interesting, I think, than the pigment they had photographed in the paper. And so I've now got this method for making, I guess, my own sort of particular color, which is cool. And yeah, this is my first attempt at, well, this is my second attempt at doing the Mars pigments, or the Mars black. The first Mars black that I did the other week, I got to this stage and everything was really nice. And then I got impatient with drying the precipitate. So I went and put it in the kiln to try and speed dry it. And that, of course, caused it to revert back to just a regular iron oxide. So it ended up being sort of just your regular sort of brown, reddish brown color as a result. And I was like, oh, that's no good. So now that I've got this, I think I might, when this settles, I'm going to use up the rest of my ferric chloride that I've got here and some ferrous sulfate and make a second batch of that, because one, we have more people watching now, and two, I want to make as much of the Mars black as I can, just because I think it's a nice pigment to use. I've always preferred blacks that are warmer than just like, you know, so like a carbon, if we just grab like some commercial carbon black here, I don't know if I'm going to be able to get people to be able to see on the stream properly, but you can sort of see like the carbon black is so flat and neutral, whereas there's this sort of brown warmth to the Mars black, and that for actual painting purposes, especially like flesh tones and shadows and stuff, tends to be a little bit nicer than just carbon black that comes out too flat. Not that carbon black doesn't have its uses, it really does. Yeah, let's just set that to the side, and let's just start making up a second batch of this. So this already had ferric chloride in it, and it's probably easier just to put water into here to get all of this out, because it's all stuck in there. Because, you know, ferric chloride is, when it's anhydrous, it's black, but it's very, what's the word I'm looking for? Yeah, exactly. Like if you just take regular like charcoal from the fire, it's too cold, which can be good for some things, but it's often just too cool. It's too cold, and you need that extra warmth. What's the word I'm looking for? Hygroscopic. So because the ferric chloride is super hygroscopic, it hydrates and gets stuck to everything. So let's just add some water into here. And just get the rest of this out of here. Although I'm not going to be able to weigh it. That's the problem. I got picture. We'll get the spatula in there. We'll try and weigh it, because we need to. The key with making the magnetite or the Mars blue of 2 to 1. So ferric chloride is an iron 3, and ferrous sulfate is an iron 2. So we need a 2 to 1 ratio in terms of those there, and then we use a base or an alkali to precipitate it out, and that's how we got to here. But we may as well use up the rest of this, because I'm not going to use it for anything else. And it's coming out all right. Would people be interested in me live streaming more often when I'm just working? Because this is generally where I work, and I just sort of potter along and, you know, make the pigments and do things that I'm doing because I'm at home every day. I know a lot of people are at home at the moment, and for me, that's normal. So how much ferric chloride do we have in this jar? 34.2 grams. All right, cool. So 34 grams in there will mean that we need half of that in this. So that's about 17 grams of this will probably do. So this one I used for the ferrous. Yep, there we go. So we need 17 grams in here. That'll do. Awesome. I'm glad, yeah. The only problem with live streaming my working process is everyone will see how clumsy I am. So the ferric chloride that I've got is very pure and very high quality. So it'll be totally fine once it all dissolves into solution. But the ferrous sulfate that I've got is just full of junk and impurities. So we'll wait for this to dissolve. Well, we'll stir it to try and get it to dissolve, and then we'll have to filter it. Currently, this all smells like rust and iron because the iron compounds have such a sort of strong, distinctive smell. Oh, we got 8 people watching. Fascinating. The ferrous sulfate's definitely not as soluble as the chloride. As you can see, like, the chloride has not almost... Chloride's clearing up pretty quickly. There's a little bit of junk at the bottom, you can see there, but that should dissolve into solution pretty quickly. Whereas if you see here, there's all these black bits floating around in here, which, because I only got this from a dye supply place for like cloth dyeing and stuff like that. So I can't imagine their ferrous sulfate is as high quality as, whereas the ferric chloride I got from a photographic chemical supply places. So they've got very pure chemicals. Let's try and get this all into solution, and we'll do another filtering of this. Okay, our funnel. Real shame, I was washing this the other day. It's hard to see, but there's a tight, yeah, there we go. There's a little crack in it, which is a real shame. When I can afford it, I'll have to get some new glassware. So just a bit of cotton wool, just jam that in there. That will filter out any impurities. Yeah, see? All this stuff in there. I don't know what it is, but it's just junk. You don't want that. Cool. You can see there, the layer of water, it's the precipitate's starting to settle. It's really cool. It's very voluminous at the moment, but it should settle all the way down to about there, which is cool. And excitingly, I got this huge Birchner funnel the other day, massive one. And it's also, yeah, it might be unreacted iron oxide. It's just hard to know, like, looking at inside here, there's just like, I've noticed there's just bits of almost like dirt and stuff in there. So it's come from some sort of big source and isn't meant to be pure. But yeah, this funnel is amazing. One, I can take it apart, so it makes cleaning it easier. And two, it just makes vacuum filtration so much quicker, because my old one was this little guy here, which this is a porcelain one. It's a really nice vintage porcelain funnel. But the surface area is just too small. So it takes ages and ages and ages to filter anything. But you compare that, like, that just makes filtering a dream. Because I must say, one of the processes that's definitely the slowest in all of this work, in all of the pigment making, is filtering. As you can see right now, we're waiting for things to filter. And, you know, gravity filtration is just so slow. My mum's here. Awesome. Yeah, gravity filtration just takes forever and ever and ever, just watching things drip through. But we've got the flask here, and this just happens to fit perfectly in it. And then with the vacuum pump, we can really filter things nice and quickly. So we'll get onto vacuum filtering at some point soon of this, but we'll wait for it to settle down a little bit so I can tip some of the liquid off before we go to vacuum filter it, because the less liquid that we have to run through the filter paper, the better, because it just takes forever. And I may just have to hold this now because this flask is too small for this. And we've also got this to filter as well. This is some of the cobalt pink or the cobalt purple sort of thing. So that liquid at the top is unreacted cobalt chloride, and at the bottom we've got the cobalt phosphate down there. And I've just been leaving this in the liquid because initially when you pour the alkaline in, it comes out a purple, but by letting it sit in the cobalt liquid for a few days, it turns more to a pink. So that's also ready to be filtered. Which we could probably start doing that now while we're waiting for this stuff to do its thing. So we'll push these to the side, and we'll get some filter paper for this, and we can probably tip this liquid off quite comfortably. Let's find another container to put that in. I have done a little bit of swatch painting with the cobalt pink. I'll have to dig that up. Oh yeah, hang on, I got it. So that's the two cobalt phosphates there. So this is the pink variety of the cobalt phosphate. And then if you heat it in the kiln at about 300 or 400 degrees, it turns to the deeper purple here, because technically what this is cobalt octahydrate phosphate. So it's got 8 extra water molecules in there. And then if you evaporate the water molecules off, you get just the straight cobalt phosphate, which is this darker purple. So that's the watercolor swatch for those. And the rest in that set coming up will be, so there's the cobalt titanium green in the last video I did, and this is the manganese blue that I've been working on, which has been quite an endeavor making manganese blue, but I'm getting closer and closer. I'll show you some of where I'm up to with the manganese blue in a moment. So let's just tip off this extra liquid here carefully. And we'll try not to lose any of the pink here. Yeah, cobalt is super versatile. It's like, cobalt can just do all of the different colors. I've got a whole drawer of just different cobalt variations. It's just never ending. Oh, all right, we'll stop there. So we've got mostly just the paste at the bottom there. So I might just get some filter paper in there. The other nice thing about this new filter is these filter papers are the right size for here. My other little one, I have to cut them down by hand, and that's just a pain. So in regards to the manganese blue, I think they did quit making it because, yes, environmental issues when done on an industrial scale are a problem. If you were to do it on small scale, you could easily do it without any sort of environmental impact. It's just that its main use wasn't for artists, it was for cement coloring. And so because manganese blue was being used as a cement colorant, they were producing enormous volumes of it. And when you're working with enormous volumes of barium nitrate, barium sulfate, and potassium permanganate, and then having to wash the pigment in hydrochloric acid afterwards, and you got to deal with all that acid waste that's yes, it becomes barium manganate, but you start with barium nitrate and heat it to get the manganate happening from there. Yeah, so the problem is if you're on industrial scales and you're dealing with all of this barium infected waste, then it's a problem. But if you were to make it just for artists these days, you could make it on such a small scale because of the amount that artists need that you could quite easily contain and look after the waste and there wouldn't be any problem. It's just that there's no desire to investigate the manganese pigments for whatever reason. It's just not commercially viable. Yes, everybody wants a whole bunch of the manganese blue. I'm still trying to figure out how to make it properly. I've successfully made it to a certain degree after a lot of work, but I haven't got it exactly right. I only just the other day got samples of some genuine manganese blue pigment to compare to, which I'll show you in a sec. I just got to get this filtering. Trying to, filter paper wasn't completely down and we're getting a bit of the filtrate coming through there, but that shouldn't be a problem. We'll pop that to the side, let that filter for the next few moments. And I can show you with the residual of this, let's see if we can get anything else out of this. So we'll get a little bit more potassium hydroxide. So what are people out there's favorite pigments to work with in their painting? Do you have any particular that you keep coming back to that you just like the working properties or the hue or the color of? Like mine are definitely cobalt pigments. They're absolutely my favorite. See, we get the intense purple initially when we put the alkaline in, but as we swirl it, it gets lighter, and then as it sits in the cobalt solution, it'll turn pink eventually. So we're just going to do a little bit more. I've actually been precipitating from this same cobalt solution like 3 or 4 times, so this is probably the last time I can get anything out of it before it's completely spent. That looks about enough. I don't think I'll do any more, otherwise it'll end up too dark, and I want to keep that pinkness that I've got there. Again, we'll set this to the side. This will probably actually need to sit for a few days before it turns pink. It'll stay in this sort of semi-lilac purple state for a little while, but eventually it'll lose that pinkness. I mean, it will gain that pinkness. And that's filtering nicely, and there we go, see? It's dropped heaps in just while I've been talking then. It's getting to, once it gets, I reckon, a little bit further down, we'll be able to tip off some of this liquid, which will be awesome. And then we can start washing all of the excess alkali out of here. And I probably need this beaker for doing the next Mars Black, so I'll just go and transfer this into something else. I'll just transfer it into here, back into here. I'll just go store this on the shelf for the next few days. Let's give this a bit of a rinse out. Alrighty. So this is finished filtering through while we've been chatting as well. So what I'll need to do, I think I'll need to rinse this out and I'll need to make up another potassium hydroxide solution. Yeah, I like the Mars pigments too. I'm not sure why the Mars pigments fell out of favor for a while with artists. Like, I know there is reasons why, because they're not the same as like natural earth ochres. They're very uniform sort of, but they still have a lot of the same sort of color properties. And so they're still really useful pigments, I think the Mars ones are. I think people just like the natural earth ochres because of their individual qualities. You know, every ochre is different to every other ochre, whereas the Mars pigments are all Mars pigments. They're all the same in that regard. So just mix up another sodium hydroxide solution here. We need it to be fairly strong, I think, because as I noticed with the first lot of the Mars Black, it wasn't until the alkalinity or the pH got to a certain point that it turned black. Initially, it was just, initially it precipitated out brown, but then as we increased the amount of the alkali, it turned black. Oh yeah, so you're mixing ochres with a bismuth yellow, and that just means that you retain the earthy quality of the ochre but get a bit more pop in the color. Is that why? I still need to get around to trying the bismuth yellow out. I haven't had the time, and I haven't really been able to organize getting any of the, like an Indian yellow, yes. All right, so we're adding our 2 iron compounds together now. And now we'll add the alkali to it. Keep stirring going. See if I can bring this in a bit closer. My webcam didn't work today, so I'm having to just use the camera from my computer. So that's why I'm on this strange angle here. But you see, it's really brown as I'm initially doing it. See, super brown, but as we go, that's probably have to make up another hydroxide solution. Give it a stir. See, it's starting to darken. There's little flecks of black in there, but we're gonna need more. And it's getting really thick again. This is Mars Black, so it's a iron oxide, but technically it's magnetite. But where did the hydroxide go? There it is. Cool. So we'll get to that last bit of stirring. We'll get it stirring, and then it's so thick now. Get that last bit in there. Get the pH up. Going. Yep, almost. There you go. See? Black now. Although I still think it needs a little bit more hydroxide. There's still a bit of unreacted iron in there. So let's just go one more little blast of hydroxide, but we'll make it a bit more concentrated. So just a tiny bit of water, because we're also running out of room in the beaker. Yeah, you can definitely see the warm notes in it. And I want to retain some of that, but I don't think I'll ever... I think there'll be a maximal amount of alkali that can go in here, and it'll get to a certain shade, and then it won't go any darker than that. There's only so black that the Mars black can go. There we go. I think that last little bit was all that it needed to finish the reaction. Let's get a bit of paper and just smear some on there and see what that looks like. Dip some of this filter paper in. So you can see it's actually quite brown. It sort of maybe needs to sit for a little bit longer. Awesome. So I'm not sure whether this needs more alkali or not. For safe measure, we'll do a bit more. I don't think the reaction's done all the way. I think it needs a bit more. This one clearly, again, with the reflection it's hard to see, but this one is much, much darker and more black than this one, still retaining a bit of the brownness. I think the problem was I didn't make a sort of, my hydroxide solution wasn't saturated enough. It needed to be. Yeah, I think that's it. Yeah, there's a lot more black in there now. So let's get rid of some of these. Pop this one to the side. Clean up after ourselves a bit. This is the main problem with doing the Mars or the iron-based pigments, is they just stain everything. They stain the glassware. Add some liquid from the large beaker to this. Ah, yeah, that's true. That's a good idea. I think I've got enough alkali in there now. So I think we'll just go back to working on this one. And our pink has nearly finished filtering through, so we'll be able to use this in a sec. So let's get some of this excess liquid off. Need somewhere to put that liquid. This will do. And we'll stop there. Yep, excellent. While we wait for those things, can you also hydrate Mars colors to make them transparent? No, so the hydrated Mars colors just end up being different colors. So all Mars pigments are iron oxide, and the more hydrated it is, the more yellow it is. And as you go down the hydration, as you get rid of the water molecules, it goes from yellow to sort of a browny color to a reddy iron oxide, and then eventually you get black iron oxide that has no water groups in there. So I don't think it really changes the transparency. It just changes the hue of the color, which is, you know, if you look at a piece of rusty metal and you look at the different transitions of colors through the rusty metal, that's just the iron oxide in different states of hydration. At least that's how I understand it. If anyone knows better in chat or anything, just let us know, because I'm not actually a chemist. I make colors, and I see this more as an art and more like, I mean, there's chemical precision to it, but it's I'm in no way like a highly trained chemist. Oh yeah, I'll go through where I'm at with manganese blue. So these are my different attempts at manganese blue. They look very pale here on the screen. Oh yeah, I've done that with siphoning things everywhere. So when I used to make beer, siphoning things out of the big brew kettle into the fermenter and having the tap still open on the fermenter so that it's just pouring out onto the floor while you're siphoning. It's like, oh, the mess you make. But anyway, yeah, so manganese blue. So these are a little bit too pale at the moment. These are some of my variations. This one's a much more blue and this one was a bit more green. And this is the professional sample. So you can obviously see there's a big discrepancy in where I'm at and where the actual sample is at. But interestingly, that is only as a powder form. So when you saturate these, the ones that I've made down, you end up with something like that. So, and this here is a lot closer to that, as you can see. So I'm on the right tone. Like I've got the shade right. The thing that I need to get better is the saturation. So, but when it's in a medium, it becomes saturated the right color. It's just in a powder form, it's too pale. And what I think that is because I'm getting too much barium sulfate and not enough barium manganate. So I'm going to have to tweak recipes and keep working at things to get it right. The problem is that the information out there on this stuff is very vague and sort of very difficult to come across. So I just have to sort of play around. So we're getting closer. Each batch I do gets a little bit better. And I'm really happy with the saturated result. And this actually, like this one here, doesn't darken much when you mix it with a medium. So it's not like I'm that far off. I'm definitely on the way. But yeah, we'll see. This already, I mean, this thing is, once you mix these up as a watercolor, they are very, you know, still very, like as you see here, they're very rich and nice color. It doesn't mean that they're not usable. It's just that they maybe will have a slightly diminished tinting strength. Not that manganese blue was ever known for its tinting strength. So we'll see how that goes. All right, where are we at with the funnel? All right, I could probably take this off and we could start funneling, filtering some of the black through now so that we can see what that's like. So I'll just find somewhere to put this. Bear with me a second. All right, just empty this out. There, got some fresh filter paper. So have most people had to stay at home recently with everything that's going on? I have a question. We're making vacuum filtration all the way. Vacuum filtration makes your life so much better. I can't talk up vacuum filtration anymore. Gravity filtration is just so slow and so tedious, and I get very, very impatient. And even vacuum filtration, depending on the pigment, can be just horrendously slow. So something like when I'm like washing a cobalt blue or something after it comes out of the kiln and I need to wash it just to make sure there's nothing soluble in there, that just filters so quickly. It's incredible. But something like the rose matters, so like the madder pigments, they're really voluminous and sort of gelatinous, and they just will not filter no matter how quickly you know how big the filter paper is or any of that sort of stuff and how much vacuum you put on them. They're just so slow. So what I end up doing with the pigments that are a bit more gelatinous is I just get a bucket and I get some calico cloth and I just stretch that over the bucket, and then I just tip the whole thing in there and just let it drip through over the next few days. And that's usually because then you get the bigger surface area from the cloth, and then eventually when a lot of it's dripped through, you can sort of pick it up and sort of squeeze it out like you're making cheese or something. But yeah, vacuum filtration is great, which I might set that up now though. We'll see how that goes, but that could be really noisy and might be you'll have to let me know if it's too noisy and too horrible, or we can go put the vacuum over in the corner there. But I'll show you my pump and my setup for vacuum filtration. So I just have this little guy here who's a hermetic pump. So it's a water pump, but it's got a reasonable strength to it. What are you saying there? But yeah, and so yeah, getting the vacuum pump was the best thing I could ever do for my work. Rubber cable on there. And ready, everybody, for the sound. There we go. Seeing how quickly that pulls through, it's incredible. It'll slow down a bit as the filter paper gets sort of clogged with more pigment particles, but you can see there, it's really nice. It's actually turned out quite a nice warm black, but there's quite a bit of depth to the black as well, which is great. Yeah, and you can see it's still pulling through quite nicely. So I reckon this would take, without the vacuum, this would take like probably a whole day, or like at least 6 or 7 hours to filter through. With the vacuum, this is probably going to take like 20 minutes, 25 minutes. But is that particularly loud coming through there? Or is it just sort of in the background? A little bit of water and rinse this through. Okay, I'm happy with the vacuum filter. I can probably put it down here. There we go, that's better. And we'll just put this over here. One thing I'm really fascinated with the vacuum filtration is you can see how it sort of like comes in little bursts. It's like it pulls up the it's like it builds up the pressure, then pulls it through, and then so it's sort of like, yeah, it's cool. I find it really interesting. Let's see. Try and see if we can scoop out a bit of the. There we go. So there we go. That's how the pigments come out. So you can see where it's thinner, it's definitely a lot more brown, but as you layer it on thicker, it's still got that blackness that you need. It's nice. I'm quite happy with that. Yeah, that should be just about right. This is going to take a while to filter, actually. It's still, I can't tip this over to show you how it looks in there. Yeah, it is very similar to a Van Dyke brown in a way. It's still up to here. So, but we're pulling through still good. So Van Dyke brown is a blend of iron oxides with a high manganese dioxide content to it. So manganese dioxide is very dark and black in quality. Sorry, I'm getting phone calls. Give me 1 sec, I need to respond to this. Where was it? Oh, I was talking about Van Dyke brown. So yeah, Van Dyke brown, I have some. I can bring that up in a sec. So this is the Van Dyke brown that I've got from Cornelison's, which is the Pigment art store in London. Very, very nice place. If you're ever in London, go to Cornelison's. It's incredible. It's like the Harry Potter wand shop, but for pigments. It's an incredible place. But In fact, let's put some Van Dyke Brown out on this piece of paper and compare them and see how they look. So I'll mix this with a little bit of water. Yeah, Van Dyke Brown is, yeah, it's about 20% manganese dioxide. So there's the Van Dyke Brown, and there's the one that we're making now. So this, you can see, is sort of, this has a much warmer brown quality to it, and this is much cooler. And that's because the manganese dioxide is a cooler, dark color than, say, the iron oxides are much warmer. But yeah, good call on it being very much like Van Dyke Brown. That's a good point. And I've always really liked Van Dyke Brown in oils. We're getting there. We're about here after all that. So we're getting down slowly. Oh, you can see through the light coming through there. You can see where the level is at. Let's go check these messages. What's the question here? I doubt that these pigments, let's see, I see that you use, for example, aluminium hydroxide and cobalt chloride. If I didn't have cobalt chloride, could I use cobalt nitrate or sulfate? What were you particularly trying to make? Because cobalt nitrate can substitute for chloride pretty easily. I've not played around with cobalt sulfate, but you can, sorry. So unprofessional of me. So usually what I do with most of my work here is with, hold on, I'll get some props. So most of my cobalt work starts with cobalt carbonate. So I get cobalt carbonate from like a ceramic glazing. So most like pottery stores or ceramic supply places will have cobalt carbonate. And then essentially if you mix cobalt carbonate and hydrochloric acid together, you get cobalt chloride. And if you mix the cobalt carbonate together with nitric acid, you'll get cobalt nitrate, and the same for sulfuric and stuff like that. So depending on what you're wanting to do, most of the soluble cobalt salts will behave similar. But yeah, it depends. What are you wanting to try and make? If you're wanting to try and make cobalt blue, so if you're working with aluminium hydroxide and cobalt chloride, and then making it precipitate and roasting that in the kiln, then you'll get your cobalt oxide with the aluminium in there. No problem. Yeah, with a lot of this pigment making stuff, it's hard to get the exact chemicals that you need. So you end up having to make things yourself. Like, yeah, I have to make all my cobalt salts myself because it's much easier just to get the carbonate and then the corresponding acid and then use that to make the various different salts that I need. So I do have some cobalt nitrate around that I made a while ago. Because there are times when I need the nitrate and not the chloride, and yeah, a lot of different things like that. You have to become creative with how you get the chemicals you need. You end up having to add multiple steps where you turn one thing into the next thing, into the next thing, and the next thing, and so forth. How long have I been going? I've been going for an hour now. My God. Well, I'm happy with how the blacks turned out. The real proof will be once we wash it and then dry it and then test it out in watercolor. But, you know, these initial, it's dark enough. I mean, it's definitely a little bit lighter and warmer, but let's compare ours to some professionally made Mars Black and see how that compares. So that's the professional Mars Black. That's mine there. So this is definitely, I mean, it's hard to tell. It's definitely a bit darker, but it's still got the same sort of tone. And maybe I like this warmth a bit more. Or maybe I just haven't reacted it properly enough, or I got my ratios a little bit wrong to get a pure black, and what I've ended up doing here is precipitating a mixture of the magnetite and just a regular amount of iron hydroxide in there, which is giving it that extra brown warmth to it. But yeah. Well, I might actually have to finish up here because I'm just waiting for this now, and I'm getting a little bit tired because I've been at this. Yeah, nice. Thank you. I like warm colors better too. But I might actually do this again same time tomorrow, and we'll check back on this. And just while everybody's stuck at home in quarantine, I must stream my working process. But I think I'm due for a break now. But I really appreciate everybody tuning in and chatting away there. It's actually really fun. I could totally get into doing it, watching me work and listening to me just rabbit on. It's good. But yeah, so we'll try this again tomorrow or the day after that, but we'll see. And I'll let everybody know how this goes, and I'll put some photos up on Instagram later once we finish this. But thank you, everybody, and I'll catch you next time. How do I make this stop? Oh, it's after midnight in America. Yeah, it's 4 in the afternoon here in Australia. All right. Good night, everyone.